Hello my dear friends, I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in the easy manner. Now in our last class we have started about what are the basics we need to be strengthened to become a pro in our organic chemistry, that I was explained. But in that last class we have stopped about the basics up to dipole moment. But to understand about the dipole moment, the very important that basic you have to understand that how the bond is forming, that we will get to know by the VBT, valency bond theory. And after that we know oxygen O2 and N2, then how that oxygen is forming the double bond, how the N2 is forming the triple bond, and we know CH4 is having the sp3 hybridization, and CH2 and H6, that is also having the sp3 hybridization, and CH2H4 it is having the sp2, and C2H2 it is having the sp hybrid. How it has came, how these hybridizations are forming, that I will explain very clearly in this lecture. So this lecture is how the bonds are forming and what is the hybridization. Clear? That I am going to explain in this lecture. Now let's start our lecture. Now in our organic chemistry, how the bonds are forming, how the molecules are forming, and at what bond length those molecules are stable, that we are going to see. Before going to start, I just want to give you one example with the very basic molecule of the H2, how the H2 is forming into the molecule. Clear? That one hydrogen atom, how they are forming into the molecule, that we are going to see. Clear? Before going to that, we need the one formula, that is potential energy, because every molecule want to try to attain the stability, or they want to be in the lower energy. Clear? For that one we are having the potential energy formula epsilon. Now charge of cation and the charge of anion by radius. Clear? Now you see, if these two hydrogen atom, this is, let assume this is H1 atom, this is H2 atom. If these two hydrogen atoms are at infinity distance, this is one hydrogen atom, now this is one hydrogen atom. If these two hydrogen atoms are at infinity distance, what happened to the potential energy between these two hydrogen atoms? Difference between the potential energy will become zero, right? Because if it is infinity, potential energy will become zero. Done? Now from the diagram also we can see one hydrogen atom are at the infinity distance. Now their potential energy is almost zero. Now comes to the attraction case. If attraction, what is the meaning of the attraction? How they will form the attraction? One hydrogen atom H1 and another atom H2. Clear? Those are attracting. When they are attracting, clear? Now how they will attract? Potential energy is equal to charge of cation and the charge of anion into the radius. Now what happened to the potential energy? Potential energy will be increased or potential energy will be decreased. Now you see, if these two are attracting, radius will be decreased. Clear? Approx it will be, when they are attracting, this hydrogen atom, what it will happen? This H1 hydrogen atom will overlap, or it will attract some region of the H2 atom. Clear? And this region we call it as the overlapping region. Why this overlapping region has been formed here? Due to the attraction. How the attraction will be happen? Now one hydrogen atom electron and this H2 atom nucleus, and this H1 atom nucleus and this H2 atom electron. Attraction is happening. Clear? Now due to that this region, some region of the H2 atom and some region of the H1 atom are overlapping. This part of the region we call it as the overlapping. Now when they are attracting, when they are overlapping, what happened to the potential energy? Now we have to see, potential energy will be decreased or potential energy will be increased. Now as per the formula, yes sir, if the radius decrease means obviously the potential energy should be increased. Okay, now let assume I was saying that due to that potential energy has been increased 100. If the radius decrease means potential energy should be increased obviously, but that that potential energy will be in the form of negative. That potential energy will be in the form of negative. How? This positive and the negative. Positive into negative will give you the negative only. Positive into negative will give you the negative. So whatever the potential energy we have seen, that potential energy will be in the negative. Clear? Now you see how much potential energy it has been decreased. Initially, when these two hydrogen atoms are at infinity distance, R is equal to infinity. Now, then potential energy we got it as 0. When these two are attracting, and when they are overlapping, their potential energy has been decreased. How much their potential energy has been decreased means minus 100, means minus 100 is indicating that 100 potential energy has been decreased. Now compared to the 0 and minus 100, which is having the lesser energy? Minus 100 is a lesser energy, right? Means molecules came to the lesser energy. When they are attracting. Next, if suppose they are repulsion. If suppose repulsion happened, how the repulsion happens, sir? Now you see, here this hydrogen atom, this is a nucleus, this is a electron. Clear? Now this is a one electron. Now this is H1 atom, this is H2 atom. Clear? From here to here attraction happen. Now here to here attraction happening. Clear? Done. Now this is a overlapping region. What is the meaning of the overlapping region? Means this H2 atom electron, now this H1 atom electron will be mutually, it will be present here. That is known as the overlapping. Done. Now you see how the repulsion will be happen. See, repulsion will be happened when, let's suppose this hydrogen atom nucleus and this hydrogen atom nucleus length, this length is x. Let's suppose this length is x, and this length we call it as a bond length. Clear? Now if suppose if I decrease this x bond length, or else I will go with the some arbitrary value. This arbitrary value is, let's suppose 10 angstroms, let us assume. Okay, 10 angstrom. This hydrogen atom H1, this hydrogen atom, when they are overlapping, this H1 atom nucleus and this H2 atom nucleus length, bond length is how much? When they have formed, these two atoms are overlapped, the length we have found that between this H1 atom nucleus and H2 atom nucleus is 10 angstrom. Now what I was decreased this bond length to the 5 angstroms. What happens if I decrease it to the 5 angstroms? More nearer this nucleus and the electrons will be comes, right? Done. What it will happen? This nucleus and nucleus repulsion will be happen, and this electron will be repel. If you decrease the bond length up less than, if you decrease the bond length to the 9, 8, 7, 5, and if you do, what it will happen? This nucleus positive charge repel, electron negative charge repel. Due to the repulsion, how the repulsion will happen? Due to the positive or negative. Now you see, due to that also radius is decreasing. Same thing, potential energy is equal to charge of positive and the charge of negative by, next, here the R radius. Here also we are decreasing the radius. But it is happening repulsion. Either it will be happen with the positive or negative. Positive into positive it will give positive only. Negative into negative also it will give you the positive only. Clear? The potential energy will be equal to plus 100. Clear? At R is equal to infinity, potential energy we got it as 0. If R is decreasing, and if it is attraction, positive into negative, potential energy we got it as a minus 100. If R is equal to either positive or negative due to the repulsion, potential energy we got it as how much? Plus 100. What does it mean? If the two atoms are at infinity distance, potential energy is 0. If the two atoms are attracting and they are forming the stable bond, which bond length they are forming the stable bond? at 10 angstrom they are forming the stable bond. Up to that 10 bond length only, that bond will be stable. Then their energy has been decreased. These two hydrogen atoms energy has been decreased and they have formed the stable bond when at the 10 angstrom bond length. Then still if you want to decrease its bond length to make it as a 5 angstrom, what it has happened? Potential energy has been increased, right? Potential energy has been increased means there is unstable in the bond. With that only they have explained very clearly. Now you see, when these two are attracting and they are overlapping some region here, you can see some region they are overlapping. When they are overlapping at some region, you see what happens? Bond length is decreased. Bond energy has been decreased. That potential energy of this hydrogen atom and this hydrogen atom energy has been decreased. Clear? This, see here, this is the overlapping region. Now from this nucleus to this nucleus, they have found that bond length between them, it is a 74 picometer. Still if you want to decrease, what it happened? Potential energy has been increasing. R is equal to infinity, potential energy is 0. When they are attracting, potential energy is decreasing. When the one hydrogen atom, second hydrogen atom bond length is at the 74 picometer. Clear? And they have formed the stable bond. How they have formed the stable bond? When they are overlapping. Due to this overlapping, this hydrogen atom nucleus and this hydrogen atom nucleus, this hydrogen atom electron and this hydrogen atom electron will be present here. Clear? And they are forming the stable bond. Clear? Due to the attraction of the positive charge nucleus and the electron only forming the bond. Still if you want to decrease that 74 picometer bond length, what happened? Bond energy is increasing. Clear? Now here whatever the concept we have studied, the concept that we have to be utilized in our organic, in the application part of the organic questions. How to apply this concept, overlapping concept and the hybridization concept in the application of the organic chemistry, I will explain very clearly. Now listen. Done. Now what we got? How the overlapping? At a certain bond length only, that two hydrogen atoms are overlapping. Clear? What is the meaning of the overlapping? Overlapping means sharing of some region. Clear? Now two hydrogen atoms sharing some region is known as the overlapping. Clear? Now this overlapping, by overlapping we get to know how the bonds are forming. We get to know how the bonds are forming. By the overlapping, we get to know how the bonds are forming. Next concept also we are going to study, that is hybridization. This is one hypothetical concept. Whether the hybridization is happening between them or not, we don't know at the molecular level. But what it will give you, very beautiful concept of the hybridization it has given. What is the shape of the molecule? Hybridization give you how the shape of molecule will have. Clear? Now in this today's lecture we are going to study about the overlapping, done, and the hybridization. Overlapping will give you how the bonds are forming. We used to see Amma, if this overlapping concept, if it is clear for you, you will not have any confusion while identifying how the sigma bond has formed, how the pi bond has been formed. How the sigma bond has been formed, how the pi bond has, which overlapping the sigma bond is formed, which overlapping the pi bond is formed. Now how the pi bonds are perpendicular to the internuclear axis, that everything will be clear for you. With the molecular orbitals I will explain very clearly for you. Then now before going to start the overlapping, first of all you have to know the shapes of the orbital. Now in the shapes of the orbital, first one is a s orbital, right? S orbital is a spherical. Done. This we know, s orbital is a spherical. Done. Next, p orbital. P orbital, we are having the three p orbitals. One is px, one is py, one is pz. Next comes to the d orbital. D orbital, we are having the 5 d orbital. What are there? One is dz square. This is dx z they have taken. This is z. Next one will be the dx square minus y square. Next one will be this is dxy and this is the dyz. Clear? Now 5 orbitals we are having. Now how these orbitals will play very crucial role in the formation of the sigma bond and the pi bond, I will explain very clearly with the orbitals. I will explain with just now we have seen the shapes of the orbital, right? Now what are the shapes of the orbital? S orbital, p orbital and the d orbital. Now we are going to study the very important concept that s orbital is directional in nature or non-directional in nature. Now directional will always leads to give which bond and non-directional always leads to give which bond. Now to understand that one, we know that in the 3D space we are having the three axes, right? 3 axes. Here one is z, one is y and one is x, right? Now here let's suppose this is a s orbital. S orbital is spherical, right? Now in this s orbital, this is nucleus. In the middle we are having the nucleus. So this s orbital electrons will be in the spherical region. S orbital electrons will be in the spherical region. Now you see, if I go along the x axis, I was getting the electron in the x axis. If I go along the y axis, I was getting the electrons on the y axis. If I go on the z axis, I was getting the electrons on the z axis. Now if I go in the middle, in between z and x, also I was getting the electrons. See, I was touching this white portion, right? Electrons. Now if I go in this manner also, I was getting the electron. If I go in this manner also, I was getting, in all the direction I was getting the electrons. Now in the 3D space you can see, this is our s orbital. This is our s orbital. Now let's suppose this is our z axis. Now this is our x axis and this is our y. Done. This is z, x, y. Now you see, in this manner also I was touching the nucleus and the electron. Done. Now in this manner also I was touching the nucleus and the electron. In this manner also I was touching the electrons and in this manner also I was touching the electrons. You can see in all the direction I can go. If I go in this manner also, I was touching the nucleus and the electrons. See, if I go in this manner also, I was touching the electrons. In all the direction, s orbital electrons I was touching, right? S orbital electrons I was touching. So that's the reason this is non-directional in nature. This is non-directional. So s orbital electrons are non-directional in nature. Clear? Now comes to the p orbital. We know p orbital, we are having the px, py and pz. Px and the py and the pz. If this px and the py and the pz, sir, what is the px and what is the py and what is the pz orbitals? Now you see. Now comes to here only. Here what you consider, this is nucleus. This yellow one is a nucleus. P orbital nucleus. How the p orbital shape will be? Dumbbell, right? Now this is p orbital nucleus. This is the shape of the p orbital, right? This is the shape of the p orbital. Now this is p orbital shape. This is a nucleus. Now here the electrons will be there, p orbital electrons sometime, and the p orbital electrons will be sometime here. Done. Now you see, here this p orbital nucleus, this is a p orbital nucleus. In this p orbital nucleus, let's suppose this is a z. This is a z. Clear? Now orbital will be, p orbital will be in dumbbell, right? In this manner dumbbell. Done. And the electron will be in the pz. Now this is pz. Now this is px and this is py. This is z, this is x and this is y. Now all the px, py and the pz orbitals are perpendicular to each other or parallel to each other. Now you have to say, Now you see, this is Pz, this is Px, this is Py. All the three orbitals are perpendicular to each other, right? If this point is clear, entire overlapping will become easy for you. If this point is clear, Pz orbital, this is Px orbital, and this is Py orbital. All the three orbitals are perpendicular to each other, right? All the three Pz orbitals are perpendicular to each other. Is it clear up to now? Done? Now, we have seen two types of the overlapping. One is directional, one is non-directional. So what is the meaning of the directional and the non-directional? Means if in all the axes, if we get electrons, we call it as non-directional. Example, s orbital, right? S orbital is non-directional. In all the cases, we are getting the electron. Already explained. Comes to the directional. What is the directional? Already explained. Px orbital, Py orbital, and Pz orbital. These three, if suppose, done. Now this is a nucleus, p orbital nucleus. This is a z. This is a Pz orbital. Done. This is a Pz orbital. Clear? Now comes to the Py orbital. Now this is Py. Done. This is a Py. Now this is a Px orbital. This is a Px orbital. Done. Just now I showed you very clearly. Right? Done. Now here you can see all these three orbitals, z, x, y, z, x, y. All the three orbitals are perpendicular to each other. Z is perpendicular to x and y, and x is perpendicular to z and y. Y is perpendicular to z and x. Clear? Done. Now based on this one, we have to see this is which one. First I was talking about the Pz orbital. For the Pz orbital, if the electrons are in the Pz orbital, this is z. Clear? Now this is x, this is y. Clear? Now if I pass a plane on the z axis, if I pass a plane like this on the z axis, I was touching the nucleus as well as the electrons. Means Pz orbital. Now in this Pz orbital, if I was getting the electrons, for the Pz orbital, if I was getting the electrons, then in Px and Py orbitals, we won't get electrons. Then in the Px and the Py orbitals, we won't get electrons. So those Px and Py orbitals are node to the Pz orbital. Clear? If you pass the plane on the z axis, like this, now you see, if here the orbital in this manner. Done. Now if you pass the plane like this, now for the z orbital you are getting the electron. If you getting the electrons on the z axis, then if you pass the plane like this, it is touching the x and y. If it is touching the X and Y, you are not getting the any electron. Now you can see. If you pass the plane like this, in this manner, if you pass the plane like this, then now Y orbital we are not having any electron, and X orbital, px orbital also we are not having the electrons. So if we are not getting the electrons, means that we call it as a node. What is the meaning of the node? Region where the finding of the electron is 0. Region where the finding of the electron is 0, we call it as a node. For the pz orbital, pz orbital is perpendicular to px and py. Pz is perpendicular to the px and py. Now px is perpendicular to pz and py. Then pz is perpendicular to py is perpendicular to px and pz. If you remember this one, now in the overlapping you will not get any difficulty. If you remember this one, then clear? Now directional and the non-directional you got it. What is the meaning of the directional? For the pz orbital, only in the z region I was getting the electron. Only in the pz region only I was getting the electrons. If in the pz region only I was getting the electron, in the px region and py region I was not getting the electrons. So p orbital is directional. P orbital is directional. If the pz orbital, if it is said px and py no electrons. If I say px orbital, then pz and py no electrons. Then if I say py, px and the pz no electrons. In these two orbitals no electrons will be there. In these two orbitals no electron will be there. In these two orbitals no electron will be there. Only electrons will be here in this manner. In this X only the electron will be there. Only in the Y only the electrons will be there. Clear up to now? So S orbital is non-directional and P orbital is a directional in nature. Now we'll see by this overlapping how the bonds are forming. How the sigma bond is forming, how the pi bond is forming. The sigma bond and the pi bond will play very crucial role in the hybridization. CH4 alkane single bond, all sigma. Alkene 1 sigma 1 pi, and alkyne 1 sigma and 2 pi. How these are forming? If this concept is clear for you, there you will not get any difficulty. Now you see. First, overlapping. For this overlapping, first you have to know internuclear axis. Internuclear axis. Sir, what is the meaning of the internuclear axis means? Now, the region where, axis where orbital overlaps leads to give the bond. Axis where the orbital overlaps leads to give the bond is known as the internuclear axis. Okay, done. In the short form I was writing it as a INA. As per our NCERT textbook, they have considered internuclear axis is a Z. As per NCERT. So we are also considering the internuclear axis as a Z. Internuclear axis Z they have considered, and they have overlapped the orbitals, and they have given the bonds with respect to that overlapping. So we are also considering the Z as a internuclear axis as per the NCERT. Done. Now first orbital overlapping that we are going to see. First orbital overlapping now we are going to see. First S and S orbital overlapping. S orbital and S orbital overlapping. Now S orbital is spherical, right? Now this is a nucleus of one S orbital. Now this is a nucleus of another s orbital. So I was considering here the INA, internuclear axis is a Z. Internuclear axis is a Z. What is the meaning of internuclear axis? Where the orbitals are overlapping. So this is a Z axis I was considering. Clear? Done. This is a Z axis. If you are getting confusion, better we'll take only up to here. Okay, done. Now this is a Z. This is a Z. Now this is a X. This is a X. Now this is a Y. This is a Y. Clear? Now I was consider the internuclear axis. Then if I consider the internuclear axis, in the internuclear axis what I will get? I will get the electrons. Along the internuclear axis, if this s orbital and the s orbital are overlapping, s orbital and the s orbital is overlapping. If it is overlapped, how they will overlap? It will share the some region of the its electrons, right? This is the nucleus of S and this is the nucleus of the S, and here the electron will be there. Clear? Now these two s orbital is non-directional. If I go in any direction also I will get the electrons. If I go any direction also I will go the electrons. So s orbital in any direction, any internuclear axis, either it may be the X, either it may be the Y, either it may be the Z. In all the direction we will get the electrons, right? So irrespective of the internuclear axis, if s orbital is overlapping, always it leads to give the sigma bond. Always it leads to give the sigma bond. How the sigma bond will be there? Now you see, when these two are overlapping, one s orbital electron, now this is another s orbital electron. Now it will be in the overlapping region. Now you see, this one s orbital electron is attracting this nucleus and this s orbital nucleus is attracting this nucleus. Now this leads to give sigma bond. How the sigma bond will be there? Now this is the nucleus of one s orbital. Now this is a nucleus of this s orbital. This is the nucleus of this s orbital and this is the nucleus of this s orbital. Done. This is the overlapping region, right? In this overlapping region only we are having. Overlapping region is a region where the more electrons will be there. Clear? Now this electron will be here. Now in the other part of this s orbital, region, what happens? Electrons is quantity is less. Done. Then it is having the less one. This is a representation of the sigma bond. This is a representation of the sigma bond. Now sigma bond is the stronger bond or the weaker bond? Sigma bond is the stronger bond compared to the pi bond. Why? Because now you see, this region, this is a nucleus, right? And this is the electron. Electron and the nucleus are nearer. Electron and the nucleus are nearer. Due to that, what happened? Strong attraction. If the stronger attraction, stronger bond will be there, right? Stronger attraction, stronger bond will be there. So this electron and the nucleus are more nearer to each other and they are forming the very strong of attraction. So that's a leads to give the sigma bond and this leads to give the sigma bond and the sigma bond is the stronger. Clear? Why? This electron and the nucleus is nearer and they are attracting very strongly. Due to that, sigma bond is stronger. So s orbital overlaps always leads to give the sigma bond only irrespective of the internuclear axis. The very confusion we will get only in the p orbitals. Now you see, we'll go with the p orbital or p orbital overlapping. P orbital overlapping. Now in this p orbital overlapping, here internuclear axis will play very crucial role. Internuclear axis we are considering it as a Z. Done. Now you see, first internuclear axis I was taking the which one? PZ orbital. I was taking the which one? PZ orbital. Internuclear axis I was considered the Z. Now this is a PZ orbital. This is a 1p orbital, PZ orbital. This is 1p orbital, PZ orbital. Done. So whenever when the p orbital overlapping, when they have given which nucleus they have taken it as an internuclear axis, that orbital always overlaps leads to give the sigma bond. Clear? If suppose if I was taking the internuclear axis as a Z, so this orbital is a pz orbital and the pz orbital. This pz orbital along the z axis always overlaps leads to give the sigma bond. Same, just now we have seen the sigma bond, right? Now this is a sigma bond. Always leads to give the sigma bond. Then always leads to give the sigma bond only. Internuclear axis orbitals of the p always leads to give the sigma bond. Why? Here in this z orbital only we are having the electrons. In this z orbital only we are having the electrons. Now you see in this, which one? This is Y, let us assume. Now if you consider this is X. For the pz orbital, Py and the Px are perpendicular. For the pz orbital, Py and the Px orbitals are perpendicular and those are not having any electrons also. If they are not having the electron, how the nucleus and the electron will be attract and how they will leads to give the bond? They will not leads to give the bond. So whatever the internuclear axis we have taken, that internuclear axis always leads to give the sigma bond. Always leads to give the sigma bond. Now you see, next we are going to see how the pi bond is formed. This is very, very important. Now listen carefully. Now, same thing. PP overlapping, INA is Z. Internuclear axis is Z. Now, orbital I was taking now PY orbital. PY orbitals I was taking. So, internuclear axis which I was considered? Internuclear axis I was considered it as a Z. Done? This is a Z. Done? This is a Z. Now this is a, which one? This is a Py. This is a Py. Now the Py orbital we are having the electrons. This is electrons. Now on the Py orbital we are having the electrons. Then this middle we are having the nucleus. In the middle we are having the nucleus. So pz orbital no electrons. Pz orbital no electrons. For this pz orbital no electrons. Now comes to the x axis. X axis also no electrons. For this x axis also no electron. For this py orbital also. Done. Now you see here with this help of this one, now I will explain very clearly. Now listen. Now with this molecular orbitals, now we'll see. Okay. Now this white ones are Z. This white ones are Z axis. Red ones are which one? Py. This orange ones are which one? X. So now the electrons are in the Py. This is on this red one we are having the electrons. Z we don't have any electrons. Now Py we are having. Now you see Py orbital is perpendicular to the internuclear axis. Which one? Z. This is Py orbital. It is internuclear axis Z. This is internuclear axis Z and Py orbital is perpendicular to the internuclear axis. Now these two are overlapping. Now you see in this manner they are overlapping. When they are overlapping, this part of the electrons and this part of the electrons are coming closer. Now here the electron cloud will be in between this nucleus. This yellow one is nucleus. But Z orbital we don't have any electron. On the Z axis, if they are overlapping in this manner, Z orbital we are not having any electron. In which orbital we are having the electron? Y orbital we are having. Now in this Y orbitals what it will happen? They are sideways overlap in this manner like this. This Y orbitals will be sideways overlap in this manner. In this manner the sideways they will overlap. Sideways. If the sideways overlapping leads to give the which bond? Pi bond. See, this is a nucleus. Electrons are here. Now when they are overlapping in the sideways like this, in the sideways when they are overlapping, in this manner, what happened? Leads to give which bond? Pi bond. Now let's consider internuclear axis Z. Now this is pz orbitals. Pz orbitals, we are having the electrons. Pz orbital, internuclear axis also Z. When they are overlapping in this manner, now you see orbitals, electrons are sharing some region, right? This is a nucleus. Now leads to give the sigma bond. Sideways overlaps leads to give the pi. Now internuclear axis leads to give the sigma. Done? Now here this sideways overlaps. In this manner the sideways it will be overlaps. Leads to give which bond? Leads to give the pi bond. Now how the pi bond will be there? Now we'll see. How the pi bond will be there. Just now we have seen, right? S orbital always overlaps leads to give the s orbital. It is along the any axis, any internuclear axis. If I go any internuclear axis in this manner also always leads to give the sigma bond only. This is nucleus, and in between these two regions the electron will be there. Now p orbitals we'll see. P orbital internuclear axis I was consider it as a Z. So this is a pz orbital. They are overlapping some region here, right? When they are overlapping some region, always leads to give which one? Sigma bond. Now you see, this is the nucleus of the p orbital and this is the nucleus of the p orbital. Now this electron now are nearer to this one. That's the reason sigma bond is stronger bond. Clear? These are hybridized orbital. So what you have to remember, internuclear INA internuclear axis orbitals always overlaps leads to give which one? Sigma bond if two orbitals are same. Means what does it mean? Means if the INA I was consider it as a Z, so PZ plus PZ leads to give the sigma. Next INA was considered Z, I was taken the PZ orbital, one PX orbital I was taken. There is no bond formation, no bond. Sir, why the no bond will be there? Now you see. Clear? Now here consider this now consider this one is a py, okay, or consider this as a x. Done. Consider this red one is a x, this red ones are the x. Done. This white ones are the which one? Z. Clear? Now internuclear axis is a Z. This is a internuclear axis is a Z. One orbital, this is a Z. One orbital, this is a Z. One orbital, this is Z. One orbital, this is X. Px only, right? Px. Done. One orbital when they are overlapping along the Z orbital or Z axis. When they are overlapping along the Z axis. Now you see this Z orbital, for this Z orbital X and Y no electrons. For this Px orbital Z and Y no electrons. When they are overlapping, for this PZ there is no electron. But Px we are having the electron, right? One electron is here, one electron is here. One electron is here, one electron is here. How they will form the bond like this? Is it possible to form a bond like this? See, electron, one orbital, electron is in white one. One orbital, electron is in X. How they can form a bond? You can see here one electron here, one electron is here. So there is no any bond formation will be there. So if the internuclear axis is Z, with the same orbitals, PZ only leads to give the sigma. PZ and the PX if you take, that is perpendicular to the pz orbital, so it will not leads to give the bond. That it will not leads to give the bond. Clear? This you have to remember. Done? Now, next, how the pi bond is forming, now we'll see. See, this is the internuclear axis we have considered. The internuclear axis we have considered it as a, which one? Internuclear axis we have considered it as a Z, let us assume. This is Z internuclear axis we have considered. Done? For this internuclear axis, this is py orbital, let us assume. This is py orbital. This is Z, INA Z. So, internuclear axis py orbital, for this internuclear axis Z orbital, already explained, right? For this is a Z, this is a Z, this is Z, x orbital is perpendicular to the internuclear axis, right? This is Z, this is x or y, let us consider y. This is Z, this is y. Y orbital is perpendicular to the internuclear axis only. You can see y orbital is perpendicular to the internuclear axis only. Done? Now, these two sideways overlap, just now I showed, sideways overlaps leads to give which one? Pi bond. How the pi bond will be there? Now you see, this is a one py orbital nucleus. Now this is a one py orbital nucleus. When these two are sideways overlapping, now electron cloud is in between here. Electron cloud is between here. Now you see this electron and this electron, nucleus distance is far away from them, right? Nucleus distance is far away from them. If the nucleus and the electron is far away from them, bond formed between them also will be weak. Bond formed between them also weak. That's the reason compared to the sigma bond, compared to the sigma and the pi bond, sigma bond is stronger. Why? In the sigma bond case, just now we have seen, right? In the sigma bond case, electron and the nucleus is nearer. So the sigma bond is formed stronger. Now in the pi bond case, electron and the nucleus is far away from them. That's the reason it is forming the weaker bond. It is forming the weaker bond. Clear? Now this we have seen. Now you see. Here these are the some internuclear axis. Consider, they have considered it as a internuclear axis, they have considered it as a Z. Now when they have considered the internuclear axis as a Z, leads to give the sigma. This also leads to give the sigma. This sideways overlaps leads to give the pi. This sideways overlaps leads to give the pi. Now zero overlapping, just now I said, right? Now zero overlapping, one is px and one is py. There is no any bond formation. How? Internuclear axis I was considered it as a Z. Now one orbital I was taken it as a px. This is px. Okay? Now here in the py, this is px, this is pz. Pz there is no electron, and this is which one? Py. This is py. Py also no electron. Only electron present in px. No electron in the pz. Now another orbital I was considered pz. Another orbital I was considered pz. Pz I was having the electrons. Then px no electrons, and py also no electrons. Then how these two will form the overlapping? How these two will form the attract? It will not form, right? Those two are perpendicular to each other. For the px orbital, py and the pz is perpendicular. For the pz orbital, py and the px are perpendicular. Then how they are forming the overlaps leads to give the one? See, that only they have explained here. They have taken one py, one px. Internuclear axis they consider Z. So there is no any bond formation. There is no any bond formation. Now by up to now you got to know how the sigma bond will form, how the pi bond will be formed. Now we'll see how the O2 and how the N2, how the F2, how the bonds are forming. Clear? Now we know O2 is forming the double bond. Now N2 is forming the triple bond. How this O2 is forming the one sigma bond and one pi bond? How this N2 is forming the one sigma bond and two pi bonds? Now I will explain very clearly. Now listen. Here first for the O2, what I was taking, here we are having the two oxygens, right? One oxygen and this is a one oxygen. Now in this oxygen we know this is nucleus and this is a nucleus. This is 1s2 This is 2s2, 2p4. Now for this one also 1s2, 2s2 and 2p4. Clear? Now valency electrons overlaps leads to give the bond in the valency of the, in the starting I was explained. Valency electrons always overlaps leads to give the bond. So how many valency electrons are there? That many to utilize to complete its octet, that it will leads to give that many bonds. Covalency already explained. Covalency is nothing but how many covalent bonds are it is forming, that is a covalency. Done. For the s orbital, for the s orbital 2 electrons has been filled. Now comes to the 2p. For the 2p, done. Here this is one 2px, this is py, this is pz. Done. This oxygen to complete its octet, it requires 2 more electrons. One electron it can accept in py, one electron it can accept in the pz. So that its oxygen octet will be complete. So this one also same. For this oxygen also, it can accept the one electron to the py and one it can electron accept to the pz. Already px electron is filled. So this if 2 electron accepted, it will complete its octet. If these 2 electrons, if it is accepted, its electron octet will be complete. Now comes to the how they will form the bond. Now we'll see. Oxygen valency electrons are 2s2, 2p4, right? 2s2, 2p4. S electrons are filled. Done. For the one oxygen, I was considering the internuclear axis is Z. Internuclear axis is Z. So internuclear axis, if I was consider the Z axis, this is one oxygen nucleus. One oxygen nucleus. Now this is one oxygen nucleus. One oxygen nucleus. Now this is one oxygen pz orbital. Oxygen 1 pz orbital. This is oxygen 2. Better I will take the different color so that it will not get confused. Now this is another oxygen pz orbital. Another oxygen pz orbital. What I said, internuclear axis orbital always overlaps leads to give the sigma bond, right? Clear? This is one oxygen pz orbital. This is another oxygen pz orbital. They have overlapped here. Leads to give the sigma bond. Leads to give the sigma bond. Done? Clear? Next we are having which we are having next we are having the py and pz. One pz orbital along the internuclear axis they have overlapped leads to give the sigma. Next one orbital which we are having py orbital, right? This is py orbital of one oxygen. This is py orbital of another oxygen. Now this py orbital we are having one electron. This py orbital we are having the one electron. Now you see here also you can see in this orbital region also one pz orbital we are having one electron. One pz orbital we are having the one electron. So one bond contain 2 electrons, right? One bond contain 2 electrons. Sigma bond it is having the 2 electrons. Now you see this is py orbital. This is py orbital. Already I explained. If it is a pz orbital, for the pz orbital, py orbital is perpendicular. Py orbital is perpendicular. Internuclear axis orbital overlaps leads to give the sigma. Now, if the perpendicular orbitals sideways overlaps, this is sideways overlapping. Sideways overlaps leads to give the pi bond, right? Sideways overlaps leads to give the pi bond. So, in the oxygen case also, this is oxygen and this is one oxygen. One sigma bond it has been formed. This sigma bond has been formed by the overlapping of pz and the pz. pz add-on overlapping leads to give the sigma bond. Next another one pi bond it has been formed. Another pi bond has been formed by the overlapping of py and py. Clear? Now 2 orbitals has not participated in the bonding. These 2 orbitals, one is 2px and 2s orbital. If these orbital electrons are not participated in the bond formation, those type of the electrons we call it as a lone pairs. I explained very clearly. So oxygen contain 2 lone pair of electrons. Oxygen contain 2 lone pair of electrons in this manner. Oxygen contain 2 lone pair of electrons. Is it clear? Now this is how the oxygen is having the one sigma bond and one pi bond by which overlapping they are forming. Now I explain. Now comes to the N2. Now N2 we are having the triple bond, right? 1 sigma and 2 pi. How it is forming now you see. For one nitrogen already I explained. Valency electrons only participate in a bond formation. This is very, very important. This is a very key point you have to remember. Valency electron only will participate in the bond formation. Now nitrogen we are having the 1s2, 2s2 and the 2p3. So s electrons are completely filled, it will not participate in the bond formation. Now here the p orbital we are having the 2pz, 2px, 2py. So this 3 orbital can accommodate the 1 electron, leads to complete sheet octet. Now you see here the pz orbital. This is a nucleus. 1 nitrogen pz orbital. 1 nitrogen pz orbital we are having the 1 electron. So another nitrogen pz orbital we are having the another electron, right? So another nitrogen also same electronic configuration. So this is a pz orbital, internuclear axis Z. So pz orbital of 1 nitrogen, this pz orbital of 1 nitrogen and pz orbital of 1 nitrogen leads to give the sigma. Then for the pz orbital, which orbitals are perpendicular? Py and the px are perpendicular. So this is a px orbital. Now this is a another nitrogen px orbital. Px orbital we are having the 1 electron, you can see. 1 nitrogen px orbital, another nitrogen px orbital. Sideways overlaps leads to give which bond? Pi bond. Done. Now next px orbital also will be perpendicular to the pz. Now this is a px orbital in this manner. Now px orbital will be in this manner. Now px orbitals also we are having the 1 electron, or py orbitals are also we are having the 1 electron. Now this sideways overlaps leads to give another pi bond. Done. Clear? In the nitrogen case, now you see in the nitrogen case, if you consider this is a z-axis. One z-axis we are having the 1 electron, another nitrogen z-axis we are having the electron. Now you see these two overlaps leads to give the sigma bond. PZ overlaps leads to give the sigma bond, we got it. PZ overlaps leads to give the sigma bond. Now this is PX sideways overlaps leads to give the pi bond. Now this is PY in the front, PY sideways overlaps leads to give the 1 pi, PX sideways overlaps leads to give the 1 pi, and PZ internuclear axis overlaps leads to give the sigma. In this manner, N2 it will form the bond. Clear? Done. Now you see this nitrogen, how the bond formation is happening. Nitrogen, this sigma bond is formed by the PZ. Done. Next, this is PY pi. Next, another PX leads to give the pi. In this manner, this overlapping, those are forming. In this manner, they are forming the overlapping, right? But this VBT concept and the overlapping concept, it has been not applicable for the which one? CH4. It has not applicable for the CH4. Now you see why it has not applicable for the CH4. Now you see carbon normally 1s2, 2s2, 2p2. Then here valence electron 2s2 and 2p2, we are having the 2 electrons. So how many orbitals are half filled? In that orbital only it will accept the electrons, I said, right? See here for the carbon it is 2px, 2py and z, let us do. Z is vacant. Px and py orbitals are there. If px and py orbitals are there, another carbon also will be px and py only. So this one carbon px and another carbon py should overlap, leads to give only 2 bonds. For the CH4, it should have only one nitrogen here and one nitrogen here. But experimentally what we are seeing the carbon is holding the 4 bonds. Carbon is holding the 4 bonds. According to the VBT, it is saying that carbon should have only the 2 bonds. But experimentally we are seeing that carbon is having the 4 bonds. How it is having? How the carbon is forming the 4 bonds? According to the VBT, why it should form the 2, but according to the hybridization, it is forming the 4. That I was going to explain very clearly in the next upcoming lecture. And see you in the next lecture. Bye.